Unit 3 review with rational numbers. So lesson 1 is comparing and ordering rational numbers and absolute value. Example 1. The 5 lowest temperatures in Queensbury, New York last February were 2 degrees Fahrenheit, -6 degrees Fahrenheit, -12 degrees Fahrenheit, 4 degrees Fahrenheit, and -2 degrees Fahrenheit. Part A, graph the temperatures on the number line below. So they provided a number line for us, which means we're going to have to label the scale of the number line. And what I want to do here is I want to look up at these temperatures, and I notice, actually the first thing I notice is that they're all even numbers. And then I notice that we have some positive values, like the 2 degrees Fahrenheit, the 4 degrees Fahrenheit, but we also have some negative values, like the -12 degrees Fahrenheit. So when we number our number line, I want to think about where I want to place the 0, and because that -12 degrees Fahrenheit is going to be located so far to the left on the number line, I'm just going to position the 0 to the middle, or even just a little bit to the right there. That way when I count to the left and I count down -2 by 2s, -4, -6, -8, -10, -12. I want to be sure that that -12 fits on the number line. All right, and we could even continue out to -16 there. And of course the positive numbers, so we're counting by 2s here on the scale. And so I look for my maximum value there, which is +4 degrees Fahrenheit, and we can see that that will also fit on our scale. So right now we have labeled the scale of our number line. What we need to do next is to label the points. And so I'm just going to go in order here. 2 degrees Fahrenheit would be located right here to the right of 0. And remember, the labels always go above the number line. I'm just going to cross that off because I finished that one. -6 degrees Fahrenheit would be to the left of 0. -12 degrees Fahrenheit, way over here to the left, even farther because it's even smaller than -6. +4 degrees Fahrenheit to the right of +2 because it's larger. And then finally -2 degrees Fahrenheit just to the left of 0 here. So we can see our points are labeled on the number line with the labels above, the scale below. And now we can even do part B, where it says order the temperatures from least to greatest. Well, the nice thing here is since they're on the number line, they're in order from least to greatest, from left to right. The -12 degrees Fahrenheit is smallest, then comes the -6 degrees Fahrenheit, the -2 degrees Fahrenheit, into the positives with 2 degrees Fahrenheit, and +4 degrees Fahrenheit is the largest, or the greatest temperature.
Example number 2, comparing more than 2 rational numbers. The question says, to write an inequality statement to compare the following rational numbers. Before we get started, inequality statement means to use inequality symbols. So I see that we have -2.6, -2 2/5, and of course -3. Now, the only problem that we have here is being able to compare -2.6 and -2 2/5. Right? It's not always the easiest to compare one with a decimal and one with a fraction. So what I like to do is I like to convert either my decimal to a fraction or my fraction to a decimal. So -2 2/5, that means 2 divided by 5. 5 goes into 2 0 times, add a decimal and add a 0. 5 goes into 20 4 times. So 2/5 is equivalent to 4/10. That being said, -2 2/5 is equivalent to -2.4. So if we were to picture these 3 numbers on a number line, it looks like the number furthest left is -3. So let's just create a little segment here between -3 and -2. Well, -3 is the number furthest left. -2.6 will be a little further right of negative 3. So this is going to be negative 2.6. Negative 2.4 will be closer to negative 2 than negative 3. So negative 2.4 is here. Remember, negative 2.4 is the same thing as negative 2 and 2/5. So when we compare using an inequality statement from least to greatest, the number furthest left is the smallest number, negative 3. Now we just go left to right. Negative 3 is less than negative 2.6, which is less than negative 2.4. Recognize that these inequality symbols are consistent all the way through. They're both less than and less than. Next, let's list our rational numbers from greatest to least using inequality symbols. So the greatest number is the number that's furthest right, negative 2 and 2/5. We know that that number is greater than negative 2.6. Because that's in the middle, negative 2.6 is further left. Lastly, negative 2.6 is greater than negative 3 because negative 3 is further left. One quick thing, back to the least to greatest, I always like to use the original number. So the original number, yes, is negative 2.4, but it looks like negative 2 and 2/5. So I'm going to rewrite this problem so that it's negative 3 is less than negative 2.6, which is less than negative 2 and 2/5.
Example 3, evaluate each expression below. We learned in Unit 3 that the bars on either side of these numbers means the number's distance from 0, or its absolute value. So we read letter A as the absolute value of negative 8 is equal to, and we do know that these bars tell us how far negative 8 is from 0. So it is 8 units from 0. The absolute value of 8 is equal to 8, because that is also 8 units from 0. And the absolute value of 8 2/3 is 8 2/3, because it is 8 2/3 units from 0. So the absolute value of any number will always be positive.